Hello everyone. So today we will be talking about balancing redox reaction especially in acidic solution. So in this slides we're going to talk about step-by-step balancing using oxidation and reduction half reaction and balancing mass and charge with proton and H2O and then complete work examples. So what is a redox reaction? So the general pattern that I follow is oil and Rick. Oil means oxidation is loss of electron, reduction is gain of electron. So the species that are losing electrons are oxidized and they are called as reducing agent. And those electrons are gained by the reducing species and they gain electrons and get reduced and they are called as oxidizing agent. So there are some key concepts associated with this are first is simultaneous process. So oxidation and reduction always occur together. You can't have one without another because if one species is losing electron, the other will gain the electrons. Electron transfer. Electron lost by one substance are gained by another. As I told, the oxidation species, when they get oxidized, they lose electron and those electron goes to the reduction species and they gain electron and become reduced. And why balance? Because everything has to follow law of conservation of mass and energy. So mass and charge must be conserved in any chemical equation. There should not be any mass generation or charge generation. So there are 6 steps of the acid balancing method. First is assign oxidation state. Identify which atoms are oxidized and which are reduced. Second is write half reaction. So after identifying which atoms are oxidized and which are reduced, you write reduction half reaction and oxidation half reaction. Third is balance atoms except oxygen and hydrogen. So leaving oxygen and hydrogen, balance every other atom. Fourth step is balance oxygen with water molecules. So fifth step is balance hydrogen with proton. So add H positive ions to the side lacking hydrogen. Sixth is balance charge with electrons. So as I said, mass and charge both needs to be balanced. So for charge balances, we need electrons. So steps 1, 2, 3. The first step is assign oxidation state. So there are certain rules. First is free elements oxidation state is 0. Monatomic ions oxidation state are equal to the charge. Oxygen oxidation state is -2 usually, but in peroxide H2O2 oxygen is -1 oxidation state. H is +1, but when it forms metal hydrides, then hydrogen is -1, otherwise it's always +1. And fluorine is always -1 because it's a highly electronegative atom. So example here, MnO4 negative plus Fe di positive going to Mn di positive plus Fe tri positive. So if we see the Mn oxidation state in MnO4 negative, it is +7. And if you want to learn more about how to find oxidation state, you can look my video of redox reaction and there I talked about how to find oxidation state. But as you can see, manganese is going from +7 to +2. So it is getting reduced because it's gaining electron, but iron is going from +2 to +3 oxidation state. So plus charge is increasing means it is losing electron. That means oxidized. Second is after finding which one is oxidizing and which one is reducing, you write the half reaction. So oxidation half is iron di positive going to iron 3 positive. Reduction half is MnO4 negative going to Mn di positive. After doing this, you balance atoms, but not oxygen or hydrogen. So you balance all non-oxygen, non-hydrogen atoms first using coefficients. So reduction MnO4 negative going to Mn di positive. Other than oxygen, only manganese atom is here and which is already balanced because they are 1 on both sides. And for oxidation part, only iron is there and iron is 1 on each side. So it's already balanced. So nothing to balance here. After this, the fourth step is balance oxygen and you add H2O to balance oxygen. So add H2O molecules to the side that needs more oxygen atoms. So reduction part, if we see, MnO4 negative have 4 oxygen atoms. So in the product side, we add 4 water molecules. So we can have 4 oxygen in the product side as well. Now the fifth step is balance hydrogen, add H positive. So you count hydrogen atoms from H2O added and then add H positive to the other side to balance hydrogen atoms. So we added 4 water molecules. That means we have 4 times 2, 8 hydrogen atoms. So we add 8 protons on the reactant side to balance hydrogen atoms. Sixth step is balance charge. And to balance charge, you add electrons. And then after that, when the charges are balanced, you combine reduction and oxidation half reaction to write the overall equation. So reduction part you see MnO negative, MnO4 negative, 8H positive, giving Mn di positive plus 4H2O. So in the left side there was initially before adding electron it was -1 plus 8, so plus 7 charge, and in the product side plus 2. So to balance charge we add 5 electrons in the reactant side so that it has plus 2 charge on both sides, reactant as well as product. For oxidation, iron 2 plus going to iron 3 plus. So in the product side, there is one more extra positive charge. So we add one electrons to balance the charge. Now here we see that 5 electrons are in the reduction reaction, and in the oxidation 1 electron. And when we write the overall equation, it should not have any electron. So we have to cancel the electrons in reduction and oxidation when we add it. So to do that, we have to make them equal. So for reduction, it is 5. For oxidation is 1. So what we're going to do, we're going to multiply the oxidation reaction with 5. So it can have 5 electron, and then add with the reduction reaction. So they can get cancelled because in oxidation, it is on the product side. On reduction, it is on the reactant side. So after doing that, the final equation becomes MnO4 negative plus 8H positive plus 5Fe di positive, giving Mn di positive plus 4H2O plus 5Fe3 positive. So here I wrote it in a tabulated version. So you write the MnO4 negative plus Fe di positive, Mn di positive plus Fe3 positive unbalanced equation. And the condition, be careful to see which condition it is, and it is in acidic condition. So you write oxidation states first. So manganese is plus 7 and it is going to plus 2. So it is gaining 5 electron. And iron is going from plus 2 to plus 3. It's losing 1 electron. So manganese is reduced, iron is oxidized. So you write reduction half reaction, which is MnO4 negative going to Mn di positive. Then balance oxygen because manganese is already balanced using water molecules. And after that, balance hydrogen using proton, H positive. And then for balancing charge, use electron, and then see the oxidation half reaction and do the same process. And after that, make the electrons equal in reduction and oxidation part, and then combine the equation to get the overall equation. We will do one more example to understand it better. So here is unbalanced equation is Cr2O7 di negative plus I negative going to Cr3 positive plus I2. So let's find out the oxidation state of each species. So in Cr2O7 di negative, oxygen is -2 and chromium is +6 because overall charge is equal to -2 and 7 times -2 for oxygen plus 2 times X for chromium. And if you equal to -2, then X is +6. So it is going from +6 to +3 means positive charge is decreasing. That means it is gaining electrons, so it is reducing. So our reduction part is Cr2O7 di negative going to Cr3 positive. Now coming to iodine negative, it has a charge of -1 and I2 has a charge of 0. So it is going from -1 to 0. That means it is going towards positive side. So it is losing electrons. So that is oxidation. So now let's come to the reduction part. You write the skeleton, which is Cr2O7 di negative going to Cr3 positive. You balance chromium. So there are 2 chromium atoms in the reactant side. So to make equal in the product, you multiply with 2. So never do Cr2 in the subscript because that will make something else. We never make new compounds. We just put the coefficient so that we can make the atoms equal. Now to balance oxygen, in the reactant side, there are 7 oxygen atoms. So we add 7 water molecules to balance oxygen. Now fourth step, 7 water molecules gives us 14 hydrogen atoms. So to balance that, we add 14 protons in the reactant side. Now there are 14 hydrogen in the reactant and 14 hydrogen on the product side. Now if we see the charge, in the left side charge is -2 plus 14, which is +12, and right side is 2 times +3 is equal to +6. So we need 6 electrons on the left side so that we have 6 positive charge on each side. Now coming to oxidation part, I negative is going to I2. So first balance iodine atom. So we multiplied I negative by 2. So we have 2 iodine atoms in the reactant and product side. Now third is there are no oxygen or hydrogen atoms, so we don't need to do the H2O and the proton step. Now we only do the charge balancing. So left side you see 2 I negative means -2 charge it has, and right side has 0. So we add 2 electrons on the right side and basically on the product side, so it can have 2 negative charge on each side. Now you see the reduction reaction has 6 electrons and the oxidation has 2 electrons. So to make the electrons equal, we multiply oxidation reaction by 2 and then add to the reduction reaction. So the final equation becomes Cr2O7 di negative plus 14H positive plus 6I negative, giving 2 chromium 3 positive plus 7H2O plus 3I2. So there are some tips and common mistakes. Always check atom balance first. Balance non-hydrogen and non-oxygen atom before touching water or proton. Okay. Second step is H2O balances oxygen. So to balance oxygen, use H2O water molecule, and to balance hydrogen, use H positive. Now the third step is that equal electron has to be present before combining in reduction and oxidation, because whatever oxidation loses electron is gained by the reduction part, and they have to get cancelled because overall equation should not have any electron. So you should have equal electrons in oxidation and reduction step before adding them. Fourth, that don't do this mistake is don't forget to check charge. So a balanced atom count is not enough. Total charge must be also equal on both sides. If they don't add electrons to the both sides, so electrons go only on the side that needs them to balance the charge, so don't add them in both reactant and product side. Sixth is don't skip verification. After doing all the step and combining them, check again and verify that everything is balanced or not. So quick reference summary. First step is write skeleton, identify oxidized and reduced species, write unbalanced half reaction. Second is balance non-oxygen hydrogen atoms and use stoichiometric coefficients for them, and then balance oxygen using water molecule, and then balance hydrogen using proton ions. After that, balance the charge, make the number of electrons equal in reduction and oxidation part, and then combine them and verify. Here are some practice problems for you to try and their answers. So in next video, we will talk about balancing redox in basic medium. And if you have any doubt, please put it in the comment. I'll try to answer. Thank you.